Hello class, and today we're going to continue on with section 5, and we're going to talk about linear models, so equations of lines and linear models. So we're going to talk about different forms of equations of lines. So we're going to talk about the point-slope form. Then we're also going to look at the slope-intercept form and how these are related. They're directly related. In fact, you can go from one to the other easily. Vertical and horizontal lines, parallel and perpendicular lines. We're going to talk about modeling data and also graphical solutions of linear equations in one variable. So how we can, what the graphical solutions look like, okay? So the point slope form, and the name kind of will give away of what we need. To get the point slope form, we need a point and we need the slope. So we have a point, right? The point gives us our x1 and y1, and we have the slope. So the point slope form, oh, this is wrong. This should be an equal sign. This is a typo. This should be an equal sign. So it should be y minus y1 equals m times x minus x1. So y and x represent any other point on the line. So all we need is at least one specific point and the slope, and we just plug it into this form, and we're done. And that's the point slope form of a linear equation, okay, or a function of a line. So if we want to write the equation of a line through this point, and it has a slope of -3, all we're going to do is use our form, right? So x1 is going to be -4, y1 equals 1, and then our slope m is -3. So we just plug it into this form. So here's our form. So we're just going to plug in for these three values, and we're done. Okay, now notice that, again, careful with the signs, -4. So we're subtracting off a -4. So of course we're going to want to simplify this to be plus. And so this would be the final answer. Y minus 1 equals -3 times the quantity x plus 4. And that is the point slope form. That's it. You're done. Box it, move on. Okay. Now, the only thing here is we use the distributive property, and they're distributing the -3. So you get -3x plus 12. And then you add 1 to both sides, and you get this. Okay. Now, this is the equation of a line, but we use the point-slope form to get to this equation of a line. But this equation of a line is in another form, which is called the slope-intercept form, because remember, this is mx plus b, where m is your slope, and guess what? -11 is your intercept, your y-intercept, because if x is 0, y equals a -11. So b is your y-intercept. So it's always mx plus b. So in this case, m is -3, and your y-intercept is -11. Okay. So again, just wanted to point that out now. We're going to cover that in a moment. But this here, if I asked you to write it in slope-intercept form, this is where you would stop. Okay. If I asked you to write it in y-intercept form, which is what we're going to talk about next, is going to be this. Okay. So now let's look at this. We want to write an equation of line through the 2 points, -3, 2, and 2, -4, and we want to write the result in standard form. So again, don't forget standard form. It's ax plus by equals c. Okay. So how do we do this first? Well, we have 2 points. Well, we're going to find the slope, right? If we have 2 points on a straight line, we can always start with the slope. Okay, so we got to find the slope, and so we plug it into the slope formula, and we find that our slope is -6/5. Okay, by just using the definition of slope. Now we can go back and we can use the point slope form, right? So this is great. So, and it doesn't matter which point we use. We can use one of these 2 points with the slope. Okay, so let's choose this one. Now we're going to use the point slope form. and we're going to plug in our slope, and we're going to plug in the x and y values of our 1 point. And now what we're going to do is we're going to simplify this, right? So this will be plus, so it's going to be a negative minus a negative, so this is going to be plus 3, okay? And so now this is 5, right? Where'd the 5 come? Well, we divided both sides by 5 because we're getting rid of this fraction, okay? So we get 5 times y minus 2 equals negative 6 times this. Okay, so now what are we going to do here? Now we're going to distribute, and so now what we're going to do? We're going to put it in standard form. We got to have it in this form. So now we're going to move all the x and the y over here. So we're going to move the x. So this is going to mean we're going to add 6x to both sides, and then we need to move the constants over here. So we're going to add 10 to both sides. Okay, and we get this. So this is our standard form, and we're done. But notice that here, if we change this to a plus, this would be the slope, point slope form. And then from there, we can just simplify things, rearrange terms, and make it into the standard form. Okay, now, as a special case, suppose that a line passes through the point 0b, so that the line has a y-intercept of b. If the line has a slope m, then using the point slope form with x equal to 0 and y equal to b gives us the following. So look at that. Okay. Okay, this is wrong. Again, typo here. This is the slope. So the slope is m, not y. Okay, so that's another typo. So here's the slope here's this point slope form, right? So all you did was plug in your special case, the y-intercept. So all you did was plug in the y-intercept for 0 and b, and then you simplified. So this just gives you mx, and then you add b to both sides, and you get y equals mx plus b. This is going to be our what? Slope intercept form, right? Where we have the slope and b is the y-intercept, just like I said earlier. And so now this arises to the next form that we're going to talk about, which is the slope intercept form. Okay, so the name gives it away. Slope intercept means that, hey, you have the slope and you have the y-intercept. So now if I want to write this in y-intercept form, okay, if I want to find the slope and the y-intercept, well, if I write this in y-intercept form, I can pick out those two items very easily. So let's solve for y and then simplify. So we're going to move the x to the other side, right? So we're going to move x to the other side. We're going to subtract x from both sides. So we're going to get negative 4x minus 10 now. And then we're going to divide everything by 5. And so if we divide negative 4 by 5, we get negative 4/5. And if we divide negative 10 by 5, we get minus 2. And so now, if we have it in this form, now we know the slope is negative 4/5 and the y-intercept is what? Negative 2. Not positive 2. Remember, it's mx plus b. So this would be plus a negative 2. Okay, and that's it. So now, what about this? Write an equation of line through these 2 points. Then graph the line using slope-intercept form. So first of all, we have 2 points, so we can easily calculate what? The slope. So let's find the slope, and by plugging in our values and the slope formula, we find that the slope is 3. And now, what we're going to do is we need to find the y-intercept. So that means we're going to use one of these 2 points. Again, it doesn't matter which one we use, and we're going to plug it into the y-intercept form, right, to solve for the y-intercept, or the slope-intercept form, I should say. Okay. So again, so we choose 1, 1. That's an easy one to use, right? So that using 1, 1 is easy. So let's use that. So we're going to plug in 1, 1 for x and y and solve for b. Okay, so the slope is 3, and we're going to plug in 1 and 1. So all we do is just solve for b, and we get b is equal to negative 2. And there we go. right? So the y-intercept is -2 and the slope is 3. Okay? Now we know that it's y equals 3x minus 2, and we can now graph the equation, or graph the function. Okay, now, use the graph of a linear function shown to complete the following. So find the slope, y-intercept, and the x-intercept. Solution: the line falls. Oh, we don't have a graph. Do we have a graph? Yeah, there we go. Okay, so should have gave the graph first. But if we have the graph, then looking at the graph, we can find the slope and the y-intercept and the x-intercept. So the first thing is the line falls 1 unit each time the x value increases by 3. So if you notice that here, right, so it increases, so as you go down, right, okay, or if you go across 3, how many units do I need to go across the x-axis before the line crosses 1 unit or however many units, right? So it's like the grid, right? So that's the easiest way to find is find, okay, where do they cross the grid pattern, okay? So in this case here, you have to go 3 units in the x direction before it goes 1 unit down. Okay, so the line falls 1 unit for every time x value increases by 3. So y rise over run, right? So it decreases by 1, so -1. So it goes down by -1 every time you go up 3 units. So it's going to be -1 over 3, or -1/3 is the slope. Okay. Now you can see that the x-intercept is what? -3, 0, and the y-intercept is 0, -1. Okay. Now use the graph of the linear function to complete the following. Write the equation that defines f. Okay. Well, we know the slope is what? -1/3, and we know that the y-intercept is what? What's b? It's at 0, -1, so b is -1. So we can write the equation by using the slope and the y-intercept. And so we know that the function f of x is -1/3 x minus 1. And that's it. That's how easy it is to use a graph. Now what about equations of vertical and horizontal lines? So you kind of already know this from previous discussions, but now we're going to actually make it obvious. Okay. An equation of a vertical line is always going to be of the form x equals a. X, the variable x, is equal to some constant, okay, that goes through the point AB. Okay, so a vertical line never has a y-intercept, right? So it's always going to be the form x equals some constant a. Okay, a horizontal line is always going to be of the form y equals b, where b is the y-intercept. Okay, so it always goes to the point AB. Okay, so in this case here, it's always going to be the form of, so if you have a point AB, right, if you want a vertical line that goes through this point, it's always going to be x equals a. If you want a horizontal line that goes to that point, it's always going to be of the form y equals b. Okay, so parallel lines. Remember, parallel lines have their two non-vertical lines. Okay, because if two lines are vertical, they're automatically parallel, right? Because all vertical lines are parallel. So what are parallel lines? Well, parallel lines are lines that never intersect, which means they have to have the same slope, right? So two distinct non-vertical lines are going to be parallel if and only if what? They have the same slope. So typically they're going to have the same slope but different y-intercepts, right? But the key factor is, or the key characteristic rather, is they have the same slope. So that's what you look for. That's the first thing you look for. If they have the same slope and they're non-vertical lines and they're distinct, they're parallel. Now, perpendicular lines, what are perpendicular lines? Perpendicular lines are lines that intersect and create a right angle. Okay, so they intersect at right angles. That's a perpendicular line. So two lines, neither of which are vertical. Okay, because if we do have a vertical line in the perpendicular, that means the other line has to be horizontal, right? So again, so it's easy to see if one line is vertical, the other line has to be horizontal in order to be perpendicular, right? So this works only for non-vertical when both of them are non-vertical, because remember, the slope of a vertical line is undefined. Okay, so you can't do this. So, but it's obvious to see when you have a vertical line that in order to be perpendicular, the other line, the intersecting line, has to be horizontal. But anyway, so this is to the general case of non-verticals. So neither of the lines are vertical. Okay, are perpendicular if and only if their slopes have the product of -1. So if you multiply their slopes and the product of their two slopes is -1, then they must be perpendicular. Okay. If you know that two lines are perpendicular, then it must be true that the product of their slopes equals -1. So in other words, the slope of one line has to be the negative reciprocal of the other line. If that's true, they're perpendicular. So if we look at this, we want to write the equation in both slope-intercept and standard form of the line that passes through this point and satisfies the given condition. So in this here, we want a line, the equation of a line that goes through this point and is parallel to this line. Well, if we know that it's parallel, then what? We know that the lines have to have the same slope. So the first thing we're going to do is find the slope of this line, because then that is going to be the slope of the line that passes through this point. Okay, so that's what we're going to do. And so we find that the slope of this line, this given line, is -2/5. So since we know that the line that passes through this point, which is what we're trying to find, is parallel to this line, then it must also have a slope of -2/5. So now we've got the other slope. Okay, so now we've got the slope of the line that passes through this point that we want. Okay, so now all we have to do is find what? The intercept, the y-intercept of that line. So guess what? Now we're just going to use the slope-intercept form to find the y-intercept of the line we're interested in. Okay, or we could use point-slope form. Okay, either way it works. Now, so they chose to do point-slope form. I would have chose to use the y-intercept form and just solve for the y-intercept, but that's okay. So here we go. So here's the point. So again, we're going to use this point. So this is going to be 5, and this is going to be 3, and then the slope is what? What's the slope going to be? -2/5. Okay, so we're going to plug it in, right? So now we're going to solve, and we're going to solve for y, right? So now we're going to use the distributive property, and now we're going to add 5 to both sides, and so now this is the slope-intercept form. So this is one of the forms we were looking for. So here's our slope, and this is the y-intercept, 31/5. Okay, and you can leave it like this. Don't try to put it in your calculator. This is the exact answer. Okay, so this is your intercept. So this is the slope-intercept form. Now, what if I want the standard form? Well, now I need to get rid of the fractions. Okay, so I'm going to multiply everything by 5. So I'm basically going now to this. So 5y equals -2x plus 31. So now I'm going to move the 2x over here. So I'm going to put y and x terms over here, and then I'll have it in standard form. And so now this is standard form. So again, this is slope-intercept form. This is standard form. Okay. Now, here's the next part. Now I want to find the line that passes through that point but is perpendicular to this line. Okay, now this is the same line that we had. So remember, we know that in order to be perpendicular to this line, it must have a slope that is the negative reciprocal of this line. Well, we found out that the slope of this line is what? Negative 2/5. So that means that the perpendicular line that goes through this point that's perpendicular to this must have a slope of what? The negative reciprocal, which means we're going to flip the slope of this line and then change the sign. So the slope is negative 2/5, so we're going to flip this and change the sign. So it's going to be 5/2. And so that's the slope of the line that we're interested in that goes through this point. So now we're going to use the slope formula again, and we're going to plug in our value again, and now we're going to use 5/2 instead of negative 2/5. And so now we're going to simplify this. Okay, we use the distributive property, and now we're going to add 5 to both sides and simplify. Now this is our slope-intercept form. So this is the slope, 5/2, and the y-intercept is negative 5/2. Okay, now what about standard form? Well, now I'm going to multiply everything by 2, okay, to get rid of the fractions. So I get 2y equals 5x minus 5, and then what I'm going to do is I'm just going to subtract 5x to bring it over here, and then I'm done. Okay, and so I get negative 5x, but again, here they don't want it equal to negative 5, so they basically multiply everything by negative 1. Okay, so in this case here, instead of having 2y minus 5x equals negative 5, they just multiply everything by 5. And in standard form, they have x first, then y. So instead of having a negative 5 here, they chose to have this. Now remember, why did they do that? Remember the conditions. A has to be greater than or equal to 0, right? That was one of the restrictions. So that's why we ended up multiplying everything by negative 1. Okay, just be aware of that. So in this case, it's 5x minus 2y equals 5. Okay, so now here's the description and the when to use. Okay, so here's the thing. So this is the equation. This is a slope-intercept form where m is the slope and the y-intercept is b. And here it says that, hey, if you need to identify, the y-intercept can be immediately or easily identified, and it can be used quickly to graph an equation. Also used to find a line that is either the equation of a line that is given through a point and a slope. So if you're given a particular point and a slope, you're going to want to use a slope-intercept form. Okay, it's very easy to use. The point-slope form is given by, hey, you have a slope and a given point that it goes through. So the ideal of finding the equation of line if the slope and the point on the two lines on the line or 2 points on line or no. Okay, so depending on the situation, you may want to use one over the other. And then in standard form, right, again, remember the restrictions. Okay, the slope is always the negative of a over b. Okay, now you don't have to memorize this because if you solve it and you put this in the slope-intercept form, that's what you're going to get. But it's always negative a over b is the slope when you're looking at standard form. B obviously cannot be 0. Okay, remember the restrictions. So all of the values a, b, and c are relatively prime, so they have no common factors other than 1. And they must also be integers. All must be integers, and a has to be positive, or non-negative rather. Okay, so it cannot be negative. Okay, so now the intercept is always going to be c divided by a, comma 0, and the y-intercept is always going to be 0, comma c over b. Okay, and again, in both cases, we cannot have 0 in the denominator. So when to use? Well, the x and y intercepts can be found quickly by just replacing the appropriate value, the appropriate variable with 0. Okay, and used to graph the equation. The slope must be calculated though. And then, of course, we have our horizontal and vertical lines. So horizontal lines are y equals b, and our vertical lines are x equals a. Okay, so again, just remember the characteristics. So it does not have a x-intercept. So the horizontal line does not have an x-intercept. So and the y-intercept is always 0 comma b, right? And it's going to have a slope of 0. Vertical lines, they have no slope. The slope is undefined. Okay, and the x-intercept is a comma 0. Okay, and so again, when to use, if the graph intersects only the y-axis, then y is the only variable in the equation. Okay, and if this is the case where you have a vertical line, then it's only going to intersect the x-axis, and it's only going to have x in the equation. So let's look at this. So in this example, we have an average annual tuition and fees for in-state students at public four-year colleges are shown in the table for selected years and graphed as ordered pairs of points where x equals 0 represents 2009, and then x equals 1 represents 2010, and so on and so forth. So y represents the cost in dollars, okay, and x represents the year, number of years after 2009. So now this graph of ordered pairs is called a scatter plot or a scatter diagram. So here we have a scatter diagram. Notice that the dots represent a almost straight line, so it definitely looks like a straight linear model here, a linear line. Okay, so we could use a linear model to represent this data or to model this data. And so here are the dates, here are the years, and here's the corresponding costs. And so this table represents the values, and then these dots represent each ordered pair, where the x-axis represents year after 2009. So this is 2009, and then this is 2010, and so on. And then the y-axis represents the cost in dollars of tuition and fees for the public four-year college. Okay, so we can definitely use a linear model to represent this data. So we want to find the equation that models the data. So in order to find an equation that models the data, we have to have 2 points, any 2 points. Okay, so we just have to pick 2 points. And so in this case here, they're going to use the first point and the last point. Okay, so basically we're going to find the average rate of change, right? We're going to find the slope using these 2 points, or what we're going to call the average rate of change. Okay, but if we choose 2 other points, we're probably going to get a different value for the slope. Okay, but again, we'll talk about that in a moment. So here we have this point and this point we're going to use. So we're going to use 0, comma 6312, and then 4, comma 8070, and we're going to find the slope of the line that connects those 2 points. And so we're going to use our slope formula, and we get that a slope is 439.5. So that means that every year, okay, the average increase in cost at these colleges is increasing by $439.50 each year, okay, from 2009 to 2013. Okay, so now what we want to do is we want to find the equation that models this data. Well, we got the slope, well, we got the average rate of change. Now we just need to use one of those 2 points as our y-intercept. Well, we don't have to. Okay, we got the y-intercept right here, right there. That point represents the y-intercept, right? Because it crosses the y-axis. So when x is 0, in other words, when time is 2009, what is the tuition? Whatever that value is. Okay, so now we've got the y-intercept right there. And so the y-intercept is 0, comma 6312. And so now we've got the slope and we've got the y-intercept. So now we can write the equation of a line using the slope-intercept form, where we're just going to plug in m and b. And so this is the equation of the line that models the relationship between what? Between the year, how many years after 2009, and the cost of education, okay, in dollars. So we know what the slope means, and we know that, hey, in 2009, what? In 2009, the cost of tuition per student was $6,312. Now, let's use this equation to predict the cost and fees, the cost, tuition and fees, at public four-year colleges in 2015. So what would X be in 2015? Well, X would have to be what? 6, right? So X is equal to 6. And so now what we're going to do is we're going to plug 6 into our equation that we just created. And so now what we're going to do is we're going to plug in 6 here and solve for y. And so now what we're saying is that, hey, in 2015, based on our model, we predict that the cost of education in tuition and fees at public four-year colleges is going to be approximately $8,949 per student that year. Okay, and again, this is for in-state students, so this is per student. So now guidelines for modeling. So first, make a scatter plot of the diagram, because one, if it's not linear, you're not going to want to use a linear model. Okay, so, but in all the cases for this textbook and this chapter anyway, they're going to be linear. But you want to make a scatter plot of the data, okay, to see that it is going to be a near linear relationship. And then step 2 is you're going to find the equation that models the data. Okay, how do you do that? Well, you involve 2 points. So you select 2 data points, and then you find the line, the equation of the line that connects those 2 points. Okay, that's it. Now, if we use a graphing calculator to solve this, okay, how do we do that? Well, we can look at this side of the equal sign as one function, and we can look at this side of the equation as another function, right? And so what we can do is we can graph this function on our calculator and also graph this function on our calculator. So let's call this f of x and this side g of x. And so we can write the graph both of these on the calculator at the same time. And then what happens is, well, what does the equal mean? When are these 2 functions going to be equal? When they intersect. And so we can visually look for that by finding where these 2 functions, f of x, let's say, and g of x, intersect. Okay. So we can write an equivalent equation with 0 on one side. So that's the other option, right? So the other option is let's move everything to one side of the equal sign, right? And make it equal to 0. So then what we'll have is we'll have a function or an expression on one side that we can call, let's say, a function, f of x. And then we'll have 0 on the other side, which is just a constant function. And then again, we can graph both of those. This will just be a horizontal line at x equal or at y equals 0, right? Right? Which is just going to be the x-axis. Or, in other words, we don't need to even graph this, because if it's equal to 0, all we're going to find is we're going to look for where this resultant function crosses the x-axis. Okay, so that's where we're going. So we're going to move everything over. Okay, so now we have this. So now we're going to simplify this, right? So we want to distribute and add like terms, right? And then set it equal to 0. Okay, now I would, again, they're graphing this. Again, I wouldn't do that. Simplify this. Make it easier to put in your calculator. But you could put this whole thing in your calculator and then find where it crosses the x-axis. Okay, And again, because the y-intercept, okay, notice that the y-intercept here is going to be negative 12. Okay, we're going to use a standard viewing window, which is just from negative 10 to 10. Okay. So we can't use that because the y-intercept is actually negative 12. So we're not going to do that. Okay. So what we're going to have to do is play around with the window and find out. So basically we can zoom out if you want, or you can play around with the window. But the point is we want to find where this graph crosses the x-axis, because that's when the graph is going to be equal to 0, and that's going to be the answer that we're looking for. Okay, and in this case we can use the 0 function on our calculator. Again, okay. So again, we're not using graphing calculators in this class, but this is to illustrate that, hey, you can use your graphing calculator or a graphing calculator to do that. And why would we do that? Is because to verify and prove and show that, hey, what we're doing algebraically, it works. Okay, so then the solution set to this equation we found is negative 12. Okay, so that is the end of this section. So again, just make sure you're keeping up with everything. Come into class prepared and ready to jump right in. Any questions, please email me. Bring them to class. If you get stuck on a problem and you want me to work on it for you guys in class, and you want me to go over it, or you get stuck on something, or you get stuck on a problem, tell me where you're getting stuck on. Show me your work, and then what I can do is I can help you, or I can do the problem and then go to that part when we get there, and we'll clarify for everybody. So again, it's up to you. So email me whenever you get stuck, or if you have a question, or if you want me to answer something in class and you're just afraid to ask, just email me and I'll make sure that I cover that at the beginning of class before we cover anything else. So anyway, have a great day. Talk to you later.